Today on Zeno Diladon, I have in for repair what looks to be an older variant of the Lightspace Venus RGB22, which is a 22-watt full-color show laser. And my mission is to make it less broken if I can manage that. So let's go ahead and plug in power, see what we get. Alright, I hear fans from the power supply is running. Connect up other things in the back. Start with the remote interlock. By the way, if you're working on a Lightspace laser and you don't know what the remote interlock pinout is, it's the two pins right here on the top row, far left side. Just so you know. Put that on. Let's see. Nothing here as far as light. Maybe you have to jump for the key switch. So I'll do that with an alligator clip. Right. Put that on there so it doesn't flee around. Hold this down. Nothing. Alright, well that leads me to suspect that it could be the back panel control board that is the issue. So I'm going to go ahead and see if there's actually power going to that control board. It should be 24 volts. I have to dig out the power pin. Hold on. Alright, let's see if there's voltage going to that. I believe is power in. Grab the meter. And we should see 24 volts. Can you see that? No, you can't. I'll read it to you. It'll be a multimeter ebook. Alright. And our power going to that is what? Nothing. Alright, so either I have the wrong plug, or there's no power getting to the back control board. So let's go ahead and take apart the back of the laser and see if we can get a better idea of what's going on. Alright, that should be everything. I should be able to kind of move the back panel off a little bit. Alright, flip that up around a little bit. Let's see. Key switch, whatnot, the ground 12, yep, that is power. Put that there. Oh, this doesn't look good. These wires are kind of exposed there on the top. What is that? Those are the LEDs. We're on. Okay, so unplug that. Yeah, it seems like we're not getting any power out of these two wires. Yeah. Go ahead and I'm gonna go find something to stick in those pins, and we're gonna test it out a little bit better. Boom. Boom. That'll help with the reading. Plug in the laser. Just to let you know, this is gonna be a little loose, so try not to have that pull around and short anything out. On. Let's see what we have on those two pins. Nothing. Absolutely nothing. And that should be coming off the 24 volt power supply underneath, and it's the same power supply that powers all the laser drivers, and they're getting their appropriate power. Okay, so it could be just a matter of bad wires for the power going to the mocha board. Let's go in and investigate. Plug that. Try and free up these wires so we can trace where they go. Make that a little bit better too. Don't like how that looks. Okay. Yeah, those go directly to the bottom of the laser. So, let's go ahead and see what those connections are on the 24 volt power supply. Make sure that those are all good. I'm going to put the back panel on with a couple of the screws so that way that's not flying around in the breeze. So here's our three power supplies. We have the two power supplies here that are 24 volts apiece in series for the galvanometers. And we have our main 24 volt power supply here for driving the laser array and for driving the main board. So what I want to do now is I want to trace out the connections that go to the main board off this power supply and see if they're good as far as connection. Oh, let's see. Which I believe are these two right here. Yes, it is those two. I'm going to take the back off. I'm going to take the back off. Back off. So here are the wires coming off that 24 volt power supply. And I'm going to check continuity on each one of these wires independently and see where we have our break. So, grab that here, grab the meter. The meter is in diode check. We're going to look for a connection that is shorted between the red positive here and say positive here. So if the connection in the wire is unbroken and it's intact, we should hear a beep. And if it's not, it'll show us open on the meter. So let's start with the red first. On the positive here on the power supply. Let's see if we have a beep. And we do. On the negative, let's see if we have a beep. We do. So why am I not getting power? Huh. Strange. Plug the laser back in. On. We have a green light here. Well, we should be getting 24 volts here. We get nothing on these wires. What do we get on the power supply? 24 volts. Okay. What the devil? Alright, well, since the diode check didn't tell which wire is bad, let's do a check on the voltage between them. So what I'm going to do is I'm going to test on here. I'm going to test the positive wire on here, and I'm going to test the voltage between this positive connection and the negative here, see if we can get 24 volts, and we get nothing. So it's suspected that the positive wire could actually be bad. Let's go ahead and test the negative connection against positive. That's good. Alright, so it is the positive side of the connection, it looks like, that is not working. That's strange. Turn off the laser again. Put it in diode check. Yeah, diode check says it's connected. Let's see what the resistance is. It's erratic. About 120 ohms. Alright, and we'll test negative. Yeah, shows 0 ohms on that one. Okay, so there's a problem with the positive connection on this laser here. So let's go ahead and inspect what that could possibly be. Oh, that can't be right. Somebody's been in here before. Yeah, so take a look at this. Line camera action away. So we have that cluster of red wires right here, which is clearly going to our negative terminal here. That's not right. So that wire needs to be moved over on the positive, and the meter must have beeped because of some reverse protection diode in the power supply or elsewhere inside of the laser. But yeah, that would do it. That would explain why we're not getting any voltage on there. Alright, so I am going to undo the 2 screws on the power supply. I'm going to move that wire over here. We're going to plug the laser all back in and see if we get any activity from the unit. So let's go ahead and do that. Unplug the laser from the power here. Make sure I don't get zapped. Alright. So that is the positive that needs to be flipped over. Okay. And we're going to put it on this side. Run that back up through to the top. Alright, and we'll secure the back panel back on the laser. Screws are out of the way. Put the laser over. Back right sidey up. Plug in the power. power is plugged in. Let's see, interlock is in. That's plugged in. Go ahead and jumper the key switch with the alligator clip again. Okay. I'll put that onto something that can't short out. Turn on the laser and see what we get. Hey, what do you know? We have status lights. So, I'll show you that. And we should get a flashing status light here once I hit this right here, which we do. Excellent. Alright, so I'm going to go get my laptop. We're going to plug in the ILDA and we're going to see if we can get some laser output. See how well it works. Alright, at this point we should be able to get something out of the laser, so let's go ahead and do this using Pangolin Quick Show to run the laser. Let's go ahead and do one of these. Enable laser. Alright, well, we got green. That's good. Turn up the brightness. I see green. I don't see any red. Red does not seem to work. Alright, well, let's put it on the red and see if it's just the potentiometer in the back. It is not. Oh, yes it is. Oh, it totally is. Okay, so, yeah, it's that potentiometer in the back. Go ahead and clean that up. Maybe pull it apart. Make sure it's all good. But, yeah, we have all of our colors, it looks like. Let's check the scanners real quick. See how they look. Scan rate 30. Okay, excellent. We'll bring the size down to 20%. Check the test patterns real quick. 20, X and Y. Okay. Awesome. Stop that. Test patterns. Alright. Laser orientation test. Do that. That is very bright. Turn that down. The fact that the test patterns start off at 100% brightness, kind of scary. Maybe tone that down a little bit. Let's see. Laser media test. Looks good. We have this inverted. Looks even better now. The alignment looks pretty okay, but we'll check that out. Long distance. Grid test. Also looks good. So the galvos look like they're in pretty good condition. No problems there. Let's close that off. Put that up, back to 50, okay. And let's go to boxes. Like that. Burn my laser safety manual. I can't live without safety manuals. Alright, well, I'll turn off the light. Yeah. Looks like a laser to me. You really can't see what's going on. There's some happy little triangles. Okay, yeah, so at this point, all I need to do is look over the back potentiometers for each one of the color settings. Make sure those are clean and working really well. And I'll go ahead and check the alignment inside of the laser heads. at a distance, make sure that all looks good, but looks like that's the biggest problem. So that's where I'm at this point. It looks good. Thing is putting the wire on the appropriate terminal block with an easy fix. Let's go ahead and try and fix another laser in this video. This is another 22 watt Venus made by Lightspace. I've got the signal and the remote interlock power already connected to it. So the only thing I need to do at this point is to jumper the internal interlock switch and then the key switch on the back. Let's go ahead and do that. I just use an alligator clip for this. Little hole here. Clip this down, just like that, and use the other side to jumper the key switch, just like that. All right, looks good. Yes. All right, see what we got. Well, no smoke, no fire. That's good. When the status light is white, we'll be able to. Well. We got output, that's good. Looks like the galvas are good. Looks like we're missing red. Do we have red? We do not have red. Green and blue, no red. Not the cable. Doesn't look like it's the potentiometer in the back. No. Well, the light's on the laser diode driver, so I assume it's getting power. Let's go ahead and see if we can trigger the modulation by using a multimeter and diode mode. So I've got my multimeter right here, and I'm going to be using diode mode. And diode mode puts a voltage on the leads, and that allows you to test diodes. But in this case, I can use the voltage, about 2 volts, on these leads to trigger the TTL, not the TTL, the signal in on the laser and turn on the laser module. So let's see if I can do that. Nothing. Disable laser. So let me show you how to do that on a working laser. We know green works, so I'm going to unplug the green right here. Boop, done. And I configure the green just like that with the multimeter. So it looks like there's something wrong with the laser driver itself. Okay. Wow. There's one major thing that it could be, and so I'm going to go ahead and check that right off the bat. So on all laser drivers, there's something that's used as a voltage reference. Sometimes it's something like a TL431 or a fixed voltage regulator. Now on each one of these drivers there is a 5-volt fixed voltage regulator right here that likes to go bad, and when that goes bad, there's no voltage reference for the constant current feedback, nor is there 5 volts going to the operational amplifiers in the unit. So got my meter here. You guys can't really see that. That's okay, I can. Let's see if I prop it up just a little bit. What can I use for a prop? Right there, is that a little bit better? Can you read that? No. Alright, you know, rule number 1, nothing is easy. Rule number 2, nothing is good enough. Once you accept those rules, life is pretty okay though. Alright, well, oh, the glare on that's terrible. It always is terrible. Alright, well, hopefully you'll be able to see what that says. Maybe, maybe not. Why does everything have to be so difficult? Alright, you know what? I'll just read it out to you. Well, we go ahead and we find a ground. So that's going to be the ground. Today we're going to test this one. We know this one's good. So we'll read the input of the regulator. You'll see that it says 24.8. On this side, it says 4.98. So that's working well. We go over to this one right here. We're going to see if we can get the output, which should be about 5 volts. So let's go ahead and test the input. 24.8. Alright. Let's see if we get 5 volts. We get 0.7 volts. So that regulator on that driver is done. So it's going to need a new 5 volt regulator on that board. Okay, let's turn that off. We're going to pull the board. Oh, move that. Get the tools. Remove the driver. Replace the regulator. The game plan has been formed. Wrong tool. Okay, so what I'm going to do is I'm going to extract the laser driver. Now there is just a couple of connections to undo. The main plug right here, which goes to the laser head. And put that off to the side. And then we got these screw terminals holding a couple of wires here too. 2 positive, 2 negative. I'm going to take those off. And I believe we have to take them all the way off. Nope, no you don't. We're good. Nice. Did I just... Come on. Okay. Right. So there's the laser driver. And what I'll do is I'll change the camera position, move the laser so we have room to work on this. We can go ahead and replace that regulator. Right, that's much better. Alright, now let's go ahead and fix this laser driver. First thing I want to do is take off the plastic backing right here. Hey, the screws are removed. The screws are removed from all of them. I wonder if that came from the factory like that. That's not supposed to be like that. Was it glued on? No. Who did that? What was glued on? Yeah, I'm gonna have to put screws in all of these. For shame, minus 5 points. Alright, let's go ahead and remove that regulator. Heat sink, prop that up on. Alright, heat up this area with the heat gun. Get the tweezers out. Soldering iron. We're good to go. So, go ahead and preheat the board a little bit. So that does help. Up like that. Clean it off just a little bit. Alright, some flux. Bring that over. Go ahead, leave that solder on. That won't hurt anything. Alright, and then get out a new voltage regulator. So, I'll be using the LM78M05. They're a good replacement, and I want the surface mount version. So, but you can replace these with a regular through-hole version if you need. It's the same pin out. Pin 1 is in, pin 2 is ground, the same as the tab, and then the third pin is voltage out. Oh, give me a new part. Alright, very good. I'm going to add some more solder to this right here. Good, like that. Put that down. Hold it in place. Make sure enough heat gets into the board so that way it's proper connection. All right, let that cool a little bit, and then I'll do the input and the output. Oh. Excellent. Okay. Looks good. Take a look at it. I think that'll do. I hope that'll do. And go ahead and clean that up. Now, I'm going to find screws and put these plastic backs on appropriately. To the screw bin we go. Right. You are, I think, a 1.5. Yes. Year 2. Here you are. Oh, I see why they didn't put the screws in now. These holes need to be drilled out bigger. But why? But why? Do I really gotta do everything myself? I do have to do everything myself. Alright. To the other tool bin. What an absolute mess. Don't do this again, Lightspace. Don't do this again. I didn't expect to say it, but it looks properly screwed now. Let's put it in. Thermal paste. Alright, that'll fill in the gaps that weren't filled in before. Back in the laser we go. Alrighty, let's go ahead and put the driver in. The black ones are the ones for positive, right? Alright, that looks good. I take this, put that over, plug that in. Good. Okay. Slide this into position. Without getting thermal grease on wires. Yeah, looks good. Looks very good. Okay. Now you just turn it on. See if we get red or if we get another blow-on regulator. I have the feeling it's going to be the former. Nothing to verify that though, like the scientific method. What a wonderful sound that was. Okay. We're good. We're good. Interlock switch needs to be put back into submission. Alright, let's go flip a button. Looks clear. Enable laser. Well, those colors still work. Let's go and try red now. What do you know? We actually have white. Looks like the red is a little bit out of alignment. But other than that, that looks pretty good. Please don't do that. Oh, red's way off the mirror. Okay. Well, it does need some alignment work, but there's a lot of videos that I've already done where I go over the alignment through the RGB dichromatin and on the galvos, as well as the alignment on the inside of the laser heads themselves. So go ahead, watch those videos out if you want to see a little bit more of what's going on inside of these wonderful machines, because they're really cool on the inside. But I think that is it for this video. I pretty much fixed the issues that are new, and it's been fun. So I hope you enjoyed, and as always, stay tuned for more.